In today's lesson, we're going to talk about dilations, and the objective is just to be able to identify whether the scale factor is construct an actual dilation and explain why a dilation is what it is. So a dilation is just simply a transformation that causes image to stretch or enlarge or also shrink in proportion to its original size. And some pictures here to show whether it's a dilation. We have the original figure and that figure being enlarged. Talking about a reflection where the image is not dilated. Maybe it's the same size. In a mirror, you have similar sizes where maybe you have a goofy mirror and so on. Taking a look at some of these, we have to keep in mind that it has to be proportional. So looking at these two rectangles, they're not in proportion because 5/3 does not equal 4/2. However, these two trapezoids have ratios of 2/2 and 3/3, creating them proportional. If you don't have numbers, you have to look at the figure to see if the figure was edited. So in this case, these two bananas, one looks a little bit smaller than the other, and they are in fact dilated. These two figures here appear to be the same size, however, they're not the same shape. Therefore, they are not. The figures here looks like the picture was enlarged slightly. And over here, we have two figures that look to be flipped. They are not. So ultimately, once you have the ability to look at two figures to see if they're dilated or not, it comes down to being proportional to each other. When you put it on a coordinate plane, we talk about scale factor. Scale factor is the ratio that you stretch or shrink a figure. If the scale factor is greater than 1, the image that you start with, for instance, triangle ACB, is enlarged, and therefore triangle A prime, C prime, B prime is enlarged by a factor that's greater than 1, creating a larger figure. If the factor that you're creating is greater than 0, but less than 1, then your image is going to shrink. And finally, to get the scale factor, once you have it, you multiply each of the dimensions by that scale factor, and that gives you the larger image or smaller image. So in this case, AB is 2 centimeters long, and then if you look at A prime, B prime, it's 4 centimeters long, and that's the dilation of factor of 2. Here are some examples I'd like you to try to answer to see whether they are or are not similar, and if they are, by what scale factor were they increased by. Here in this figure we have dimensions of 4 and 2. A prime is on the outside, therefore the image was enlarged. The scale factor was 2. It's greater than 1, therefore it's an enlargement. Here we have A prime and B prime on the inside, and that factor was 8 to 2. So it would be 1/4. In this example here, A prime and B prime are on the outside, 6 to 2, 9 to 3, scale factor of 3. A prime and B prime are on the outside, or on the inside, excuse me, and it goes from 12 down to 4. We're dividing by 3 or multiplying by 1/3. 4 to 8, scale factor of 2. 8 down to 4, scale factor of 1/2. The two circles here have 3 and 9. The scale factor would be 3. It's greater than 1, so it's an enlargement. Over here, C prime is on the inside. Goes from 2 to 12. 12 to 2, excuse me. Therefore, it would be 1/6, and it's still a dilation, but it's less than 1. The first question underneath this video is going to be this question here, so you can answer it at your own. The ratio by which the image stretches or shrinks is known as the scale factor. True or false? You can answer that question now and then continue on with the video. Similar images are created by multiplying the same scale factor to each dimension. In this case, our original figure, ABC, has each side multiplied by a scale factor of 2. So every time we create a new image by multiplying each side length by the same scale factor, we create similar figures. The next question on your question at the bottom of the video says, dilations create similar images with the change in length of the sides or area. Is this true or is this false? Please answer that question now. When we go to create a dilation, we use these images here and create a dilation where the scale factor is used. And from there, we create the points using the scale factor. For instance, the sides of 2 and 2 are AC and AB. If we multiply both of those sides by 2, we get a side length that's a little larger. Matter of fact, it's 4 centimeters instead of 2. In this example here, you have a square. Notice the 4 points. Find the new ordered pairs of this dilated figure using a scale factor of 2. Take each ordered pair and multiply the x and the y coordinates by the factor of 2. That will give you your new ordered pair, and your side lengths of that square should be multiplied by 2. Therefore, A prime, B prime, C prime, D prime should all be distances of 4 because 2 times 2 is 4. Find the new ordered pairs of your square now. The following questions are going to be at the bottom of your video. Please continue to hit pause and answer these as we go through them. Answer the question, true or false? The two rectangles shown are dilated images of each other. Next question. A table is 3 centimeters wide. After the dilation, the table is 6 centimeters wide. Calculate the scale factor for this dilation. If a balloon of diameter 2 is dilated with a scale factor of 1.5, what is the diameter of the new balloon? In this figure, you'll notice that the light source that we used for the lines in class have created distances of 2 and A for the small figure and 4 and 6 for the large. Your job is to find the value of A that would make this a true dilation. And finally, what is the scale factor of the dilation that you see? Any point that you use should follow the same scale factor. Looking at the ordered pairs, you should be able to determine what that scale factor is. Please answer the following questions at the bottom. If you need to rewind to look at any of the questions, you may. Otherwise, answer the question at the bottom and submit at the end.